A 65 kilogram athlete in a long jump event leaps with a velocity of 7.5 meters per second at an angle of 30 degrees to the horizontal. For the following questions, treat the athlete as a point mass. Ignore air resistance and use G equals 9.8 meters per second squared. Now, point mass just means that you assume the athlete is a speck, right? A speck that weighs 65 kilograms. Because otherwise you have to deal with air resistance and the body shape and stuff like that. So for all of these problems, always in exams and stuff like that, you just assume it is a tiny point of mass that is flying through the air. Okay, that's what point mass means. What is the athlete's velocity at the highest point? What's the first thing we're going to do?
Draw a diagram.
Draw a diagram. Wonderful. So, our initial vector looks like this. It is, no, that's not 30 degrees. Let's make it a bit better. That is 30 degrees to the horizontal. We know that is 7.5 meters per second. And our athlete is going to travel in a parabolic arc. Okay? They're always going to be in a parabolic arc. How are you? No. All right, so our athlete is traveling in a parabolic arc. We have 7.5 meters per second and 30 degrees. We want our athlete's velocity there. What do we need to specify a velocity? What do we need to, what is our answer going to look like? What do we have to give?
Magnitude and direction.
Magnitude and direction. Excellent. By looking at this, can you tell straight away the direction of the velocity? Directly horizontal. How do you know? Exactly. This is like if you had a ball and you threw it up vertically. Okay? At the very top of its peak, for an instant, it stops moving vertically. Right? As it's changing direction and then comes back down, at the very peak, it stops moving for an instant. Now, at our peak, even with a horizontally moving body, at the peak, the vertical velocity, when it changes direction, is 0. So at our peak, our athlete has 0 vertical velocity. So what we need to figure out is what the horizontal velocity is going to be at the peak. And we do that with trigonometry. So now, by the way, I usually give these, you may see these written differently in other books. My convention, I like to write U, okay, you know initial velocity is U, V for vertical. Oops. UV and UH. So we want UH. We want to find UH. And so from trigonometry, the cos of theta is equal to the adjacent on the hypotenuse. So if we rearrange this, our adjacent side is going to be equal to h cos theta. So our adjacent side is the one we want, UH. So h is 7.5 multiplied by the cos of 30, which is 6.5. Rounding? It's 6.5 meters per second horizontally. Okay, so the reason that we just say horizontally, there's no vertical component to this velocity. At the very peak, the vertical component is 0, just because it's just at that point it's changing direction. Okay? So all you need to solve this to find the peak is that horizontal component of the initial velocity. Okay, UH, once you've got that, because our horizontal speed doesn't change anywhere throughout the arc, that UH is going to be the same horizontal velocity whether it's at the start, at the end, or at the peak. All right. Any questions so far? Are we okay with this? All right. What is the maximum height gained by the athlete's centre of mass during the jump? Okay. So again, the information that we are given is this. You know that's 30 degrees. We know this is 7.5. And we want, at its peak, We want that height. So if you're looking at maximum height, the key to this is you don't actually need to worry about the horizontal component at all. Okay, this is why it's really, well, it's essential to break this into its two components. So I'll show you what I mean. This, remember, is UV. And so if we work this out, sine theta equals UV on H. So again, we rearrange. UV is equal to 7.5 sine 30. So that's our initial velocity in the vertical direction. And that is 3.75. Okay. So we have our initial velocity in the vertical direction. Let's just only look at the vertical direction. Okay, pretend there's no horizontal component. Our jump is just going up then straight down. Remember that the horizontal component doesn't make a difference to how long it's in the air for. Okay, so if we're just looking at how high it goes, we don't need to worry about the horizontal. This is now a Suvat equation. Okay, what are we looking for? What do we want to find? S. We want S. We want this distance here. So we want S. Okay, what do we know? Sorry? V equals 0. Good. At its very peak, our vertical velocity is 0. Remember? At the peak, vertical velocity is 0. What else do we know? U? We absolutely know U is 3.75. What else do we know? We need one more thing. We need 3. Good. Our acceleration is negative 9.8. Now don't get fooled here. Our initial velocity is going upwards. Our acceleration is going downwards. One must be positive, one must be negative. Okay? Remember, negative in physics just tells you direction. So if it's going up and coming back down, as long as if U is positive, A must be negative. You can do it vice versa and it will still work. Okay, so now we have all these. So you have a look at your Suvat equations and you find one that fits that information. And it just so happens we have V squared equals U squared plus 2AS. Okay, V squared, that's easy. 0 squared is 0. U squared.
14.06.
Thank you. 14.06 plus 2 times negative 9.8 times S is what we want to find. Now if we can rearrange this, because this whole thing at the end is going to be negative, we can just move that to the other side. And so we get 2 times 9.8 is 19.6. So 19.6S is equal to 14.06. Yeah, that one? Yeah, 19.6S. Okay, so now it's just a nice little bit of division. Divide both sides by 19.6 and we get 0.717. meters. So the maximum height our athlete is going to reach is 0.717 meters, or 71.7 centimeters. Okay? So if you have constant acceleration, remember you can use your Suvat equations. And in this case, we do have constant acceleration. The only force is acting as gravity downwards, so we can use our Suvat equations. Okay. Last one, assuming a return to the original height, so assuming the athlete jumps and lands at the same height, what is the total time the athlete is in the air? All right, again, Suvat equation. Now, when you have a problem like this, it's useful to only consider the first half of the jump. Okay, so let's consider our athlete going to there. And you'll see why in a second. Okay, so what do we know? We know V. Oh, sorry, we know U. Oh, we also know V. U is 3.75. Okay, and again, I'm just talking in the vertical vertical direction. U is 3.75. V is 0. What do we know? Acceleration. Negative 9.8. You're right. I like it when we have these three, and we're looking for time because we can use the easiest of the Suvat equations. V equals U plus AT. We know V is 0. U is 3.75 plus negative 9.8 T. Rearrange. 9.8 T is equal to 3.75. And so T is going to be equal to 3.75 divided by 9.8. 0.38. .38 seconds. We are not finished. Why not? You have to double it. Very good. That 0.38 seconds is the time it takes from the athlete to get from the ground to the peak. He's got to get back down again. Okay? Now, in any projectile motion problem, you can assume that the trajectory is, the start of it is the same as the end. Okay? It's just a mirror image. So if it takes 0.38 seconds to get to its peak, it's going to take 0.38 to get back down again. Okay? So our time, we have to multiply that by 2. So our total time is going to be 0.38 multiplied by 2, which will give us 0.76 seconds. Now, something I want you to get into the habit of is what I call the common sense test. Now, you may have heard me use this before. If you have a look at these, and if you imagine yourself as a long jumper, okay? Our maximum height, 0.7 metres. Does that sound reasonable? If you're doing a long jump, do you reckon it sounds reasonable that you get, 3/4 of a metre off the ground? Sounds reasonable to me. Does it sound reasonable you'd be in the air for 3/4 of a second? Yeah, sounds reasonable. If you get 5 seconds here, you know something's probably gone wrong. That's the common sense test. Read your answer and just make sure that it seems logical.